All right, printers, here we go. Printers are fascinating. Actually, I don't find them very fascinating. This is simple information. Yeah, it's a bunch of stuff, that's for sure. But it's not as detailed as bit rates and that kind of thing. Really what we're looking at is, when you go to buy a printer, these are the things, right? This is what you're looking at when you're trying to consider, what should I get? How much room is it going to take up? How much paper will it hold? How many things will it print in a day? That kind of thing. How fast will it print? And is it a good quality? And then how much does it cost per page? So most of the printers we have around EAC, the big ones, really big ones, those things can print thousands of pages a day without even blinking. Now, people have kind of figured this out. If you go to, actually, I don't even know if they sell them in the auctions anymore, but those machines, they'll have them for 6 or 7 years. And so then they'll finally, kick it out the door. But so many of them, like coming from our labs, they don't really get hardly used. In 7 years, they get used maybe half of what they could have gotten used in 1 year. And so they really are underutilized and great things to buy if you can get your hands on one. But that's really dealing with the capacity of how much can it print without really having trouble. You would not want to go into a large environment and say, this printer is going to be shared across 250 people. I think I'll get this little laser jet printer. It's going to die within a couple of years. It'll be overused. So anyway, what do we got? We got inkjet printers, which actually shoot a little ink bubble, and the bubble just bursts on there. And it's so microscopic, right? They can really produce high quality output. They're relatively inexpensive. The disadvantages are prints do tend to fade. If they get wet, you're in trouble. And then the inkjet, as you know, they'll get clogged up and then you'll have a problem. Lasers are a lot more reliable. They'll have a higher quality output for black and white, not for color. They'll print really fast and they deal with the huge jobs, without a problem, but they're more expensive. And they say more difficult to maintain it. I don't really think they're more difficult to maintain, but it would be like saying, I'm going to use the printer in the right place. It's a big printer, 250 people are going to print to that printer. And this inkjet has one owner and they're the only ones printing to it. Then yeah, this one is more difficult to maintain because there's more moving parts in there. And you can just get a job repairing printers, honestly. So I knew somebody that used to do that. Anyway, you get a chance to install some peripherals, connect a monitor and so on. And now we're going to move on to the big stuff of storage. Storage is a huge thing. And this is another thing that has to be completed before we do any of the storage labs. Otherwise, it's like, oh, wow, don't really understand what's going on with storage. I have put storage into 3 or 4 of my courses instead of just this one because it's something you use all the time and students are not used to using it the way you would in IT. Yes, definitely plug in my USB flash drive. I can format it. I can even maybe change the format to exFAT instead of NTFS. But beyond that, it's like, what are we doing, right? They don't really know. So the different types of storage has to deal with how actually things are stored on the volume or on the physical drive itself. The old school is hard disk drive. That's why they're so much cheaper, because this has been around for a very long time. Let me see if I can find a first IBM. IBM wasn't necessarily the first to make the hard drive. But we'll see a picture of one here. There's one. Look at that. Look at that. So that's a hard drive unit. I think it was like 5 megs probably, and these are all the different platters on it being loaded off. All these platters. So he's pulling one out. They were more durable. You didn't want to go around touching them, but you could just clean them and put it back in. But in order to get the speed and the size that we have now, they're enclosed. You don't touch them. If you do, you're in trouble. It's got a very minuscule head that runs across the surface. Doesn't run across the surface. It's just barely above it. And it's so flipping cool. I always tell the story because it's cool. At the first place I worked, they still had backups on tape, real tape. And then I was talking to one of the programmers. He's like, we actually have a magnifying glass that you can look at the magnetic surface of and see where the ones and zeros are. I was like, what are you talking about? Because the tape, like, you take an old 80s cassette tape or anything like that, it uses the same thing as a hard drive. It's basically magnetic and storage. And what it does is when you want to say, I'm going to store some data, it'll take a certain area and pile up the magnetic sensitive particles on there to create something that the head will just bump across, right? And see that as a one. And it's incredible. Yeah, and he showed me. He brought over a tape. He found it a couple of days later. He found it, and you could look in there and you can see it. You can search for it, and you won't see that. Anyway, hard disks store a large amount of data, so they're really cheap, and you get a lot of storage out of them. They're kind of fast. Compared to SSDs, they're not. And they usually come in two form factors, a 3.5, which is talking about the platter, and a 2.5, which is talking about the platter. And so, like I said, an external hard drive, I've got one right down here that I do backups on. I'll just unplug it real quick. And there it is. It's in this case. I can see it in there. And that's an external 3.5-inch hard disk that would go in a standard computer. It's got a SATA connector on it. And the 2.5s usually would go into a notebook, or again, a small portable hard drive that you could use that's powered straight off of the system. But the capacity is ever increasing, up to 18 terabytes. And so when you look at the cost per terabyte, hard disks are cheap, relatively inexpensive. And then it has a couple of things. For instance, how fast can it read and write data? Well, that depends on how fast that platter or platters, because there's more than one platter in there. Usually you have a platter, read and write head, read and write head, platter, read and write head, read and write head. And how fast that spins will affect how quickly the data can be pulled off of that. In other words, how many times in a second can I see the data I need to read or write? And that is done in revolutions per minute. So standard, I would not want to go below 7,200 RPMs. 10,000 is a better standard, and 15,000 is what they use in servers. Lots of times in your notebooks, you're dealing with 5,400 RPMs, and those are relatively slow. But why they do it is because this takes more power to do, right? Hard disks have a controller. These days, that's usually built into the board. This, for instance, has a USB converter that plugs into USB 3.0 or 2.0. And of course, that little card that's doing the converting is also the controller for the hard disk. In other words, I know how to use the hard drive. So different kinds of hard disks that are out there. SCSIs are old, SCSI, small computer serial interface. That was used for a very long time because they're very fast. These are still used on servers, by the way, still used on servers. These are the old ones. I've got a ton of those, PATA drives, parallel attached storage. And so this is what we've been using for the last 22 years. That's where it started to transition. So this is serial attached storage, and it supports hop swapping. It's a lot like SCSI. So IDE was not like SCSI. SATA is a lot more like SCSI, and it's much faster, and the cables are much easier to connect. And that's what you'll use in class is SCSI. All right, and then optical drives and your flash storage. And then the SSDs that are actually SATA SSDs. This is a SATA SSD. You don't have a SATA connector. And then ones that you're plugging in USB or Thunderbolt. But internally, what is it going to have? It's going to have a SATA connector. You're going to see one of these with a SATA connector in there. And then they don't mention the newest ones, which are M.2s. So let's take a look at an M.2. These are PCIe connector, and this is what they look like. These are some older ones, but it has this connector here, and then this screw that holds it down right there. And they are really, really fast, and it uses M2's connectors are PCI Express 4 or 3s, and that's what they are connected with. M2 specification support NVM Express, which anyone that I bought is usually that. They also support PCI Express. Those are a little cheaper. But basically what you're saying is, this is my hard drive. I'm going to take the same thing that was in this SSD here, that's going to connect right into my serial ATA, my SATA, and I'm going to just put that on a chip, and I have a special M2 connector on the board, and I just pop that in, screw it down, and I'm ready to go. Super fast, cheaper, but if you don't have one, this upgrade is a really good thing to do. This one of the most important things I'm going to tell you here is that these devices, these hard disks, and you'll get a chance to do this in class, these hard drives, Windows from a flash drive to the hard drive will take about 15 minutes to install, and about 3 minutes to boot. On flash storage in the solid state drive, it'll take about 7 to 10 minutes to install, and then it'll boot in about 20 seconds. So if you've got an older computer and you know you're going to have to keep using it, you can transfer all your information off of that hard disk and put it on an SSD and put that SSD in. And for quite a while, you'll be very happy because your computer will react so much quicker because it's not waiting for that thing to seek and so on. Also, a huge benefit in notebooks that have the slower drives. So usually you can take out that hard disk that's in there, put one of these in instead, and you'll see a massive performance boost. Let me know if you want to do that. I can show you a video on that, but that's just one of the simple upgrades that you can do on a notebook or a PC to give yourself much more speed. One of the things I tell people in the lab is that even if you want to just buy a small one, you can have Windows boot off of one that's only like 64 gigs in size, and it will dramatically speed up your system. So you don't necessarily need to buy the terabyte one, right? That's what I'm saying. In a desktop system, you can buy a much smaller one, install Windows to that, put your main important files on that, and then use your hard disk for everything else. And it'll still speed things up tremendously. All right, that is some hard disks basics, and we will continue from here.